In previous courses, you learned the distributive property. When using the distributive property, we need to combine like terms. For example, 2x squared and 7x squared both have an x squared. So these are like terms. 3y and 3y squared are not like terms because their variables do not have the same exponent. As long as the variables are raised to the same exponent, we can combine the coefficients. In this case, we would be able to add 2 plus 7 to equal 9. So 2x squared plus 7x squared is equal to 9x squared. When we are multiplying 4x times the quantity 2x plus 1 minus 7 times the quantity 2x plus 1, we would distribute the 4x to the 2x plus 1 to get 8x squared plus 4x, and we would distribute the 7 to the 2x plus 1 to get 14x minus 7. The 4x and the 14x are like terms, so we can combine those terms to get 8x squared minus 10x minus 7. In the task you did today in class, Pascal's Pride, you learned about and practiced different strategies for multiplying polynomials together. In your previous math courses, you learned how to multiply two binomials together, as shown here. How do the strategies you practiced today, such as area models, boxes, and distributing, compare to what you have previously learned about multiplying binomials? To review, let's compare the two different methods: multiplying 2x minus 1 times the quantity x squared minus 4x plus 7. Here is the area model and boxes. After combining like terms, we are left with 2x cubed minus 9x squared plus 18x minus 7. Here is what it looks like distributing. You have learned about function transformations in your previous math classes. Transformations including shifts, dilations, and reflections change the position and shape of a graph in the coordinate plane. Consider, for example, the original f of x equals x squared function and the transformed graph g of x equals 3 times the quantity x minus 1 squared. What changes do you notice in the graphs shown here? Note, though transformations change many aspects of the graph, many characteristics, including its general shape and behavior, stay consistent. To prepare you for these Go questions, let's review how different transformations affect a graph as shown here. In order to graph a transformed function, you can always create a table of values and plot specific points, but you can also identify the original function and determine how the transformations affect the graph. For example, in the equation y equals the quantity x minus 2 squared plus 1, the parent graph y equal x squared has been shifted 2 units to the right and 1 unit up. Refer to the following parent functions and graph the transformations in these Go problems.